Hello, welcome back to the last section. Quinn. Quinn is the CEO of Daily, and Daily have been a big supporter of ComCon, so thank you very much for supporting us. I'm really looking forward to hearing what you've got to say. So yes, we'll pass it over to you, and then we'll get back to you with questions. So take it away, Quinn.
Dan, thank you. Thank you for all the amazing work on this event. As always, it's super fun to hang out with other WebRTC people. Today I'm going to talk about WebRTC and what I think is an opportunity for a bunch of us in the community to teach a whole new cohort of folks about WebRTC, because there's a really exciting new set of use cases for real-time AI. GPT-4 was released March of last year. And we had actually started doing some things at Daily before that with GPT-3.5, because GPT-3.5 was really good at things like summarizing transcripts from video calls. Super useful non-real-time or real-time adjacent use case. GPT-4 actually felt like you could have a real conversation with it. And a lot of what we all do with WebRTC is facilitate people having conversations of various kinds. This felt like a new and really interesting one. I'll back up just a little bit, though, not assuming everybody here knows me. I don't know all of you, but I'm excited to meet all of you after this. Daily's been around since about 2016. We think of ourselves as kind of a plumbing company. We set out to build a really great WebRTC tech stack and infrastructure for other developers to use. Today, we have a few thousand customers and SFUs in, depending on how you count, 80 or so availability zones across a few different clouds. And we have SDKs for all the platforms you would expect us to have SDKs for, at least I hope so. After GPT-4 came out, we started building things, mostly experimentally, sometimes because customers ask us for them. So I just want to do like a little bit of a walk down memory lane of how we got there, how we got here today. This was, I think, the very first thing we built for a customer using GPT-4 and real-time stuff. Customer asked us how they could
Creo que hay muchas posibilidades. Por ejemplo, vemos mucho interés por parte de clientes de telesalud.
Well, I think there are many possibilities.
Hay veces que necesitas a un médico y
For example, we see a lot of interest from telehealth clients. For example, there are times when you need a doctor and that doctor speaks the same language as you.
Pues creo que hay muchas posibilidades. Estamos viendo mucho interés por parte de clientes de telesalud.
Well, I think there are many possibilities.
Que no habla tu...
So the architecture there is the audio is being transcribed, then it's being sent to GPT-4 with a prompt that says, basically just please translate this audio from Spanish to English. And then the transcript is being sent to, you saw Azure and PlayHT overlays. Those are two voice models to two different text-to-speech models that we were trying out. So there's these building blocks. We were very early in trying to figure out ourselves how these building blocks fit together and what they could do for our customers. We got a little better as we built more of these things, learned what was hard and what you needed to do for a good user experience. One of the things we learned pretty quickly was you have to handle interruptions gracefully for a whole bunch of use cases, or at least for conversations to feel natural, because sometimes the voice bot keeps talking and a user actually wants to do something else. So this was, I think, the first time we had a really good, clean, reusable chunk of interruption handling code wired up.
I'm your friendly chatbot, here to assist you with any questions or tasks you have in mind. How can I help you today?
Can you tell me a joke?
Absolutely. Why don't skeletons fight each other?
You always start with that one. Give me a different joke.
All right, I'll give it another go. What do you call fake spaghetti?
I've heard that one too. Come on, maybe just tell me a fact that I don't.
Tell me a joke is one of our go-to voice bot testing things. So I think we know all the jokes that all the LLMs will tell you with the standard context. You can see that we also had a little bit of an animation there. One of the exciting things that I think is going to happen this year is that real-time video and avatar models are going to become available. They're not quite there yet. That animation was a sort of anime-style, like barely lip-synced loop of 15 or so frames for a speaking 15 or so frames for a non-speaking state actually works pretty well. Our brains are pretty good at interpolating characters into, you know, the sort of speaking state. But I think new models are coming, and we're going to be able to do sort of real video avatars not very long from now. We kept building stuff. This is a example we built of LLMs talking about extremely important world historical topics.
In my firm opinion, a hot dog is a sandwich. Defined by Merriam-Webster, a sandwich consists of 2 or more slices of bread, or a split roll having a filling in between. Hence, given that a hot dog fulfills these clear and consistent criteria, it undoubtedly classifies as a sandwich. Now, let's delve into detailed argumentation, shall we?
Using a dictionary definition doesn't make a hot dog a sandwich. After all,
So these are 2 different LLMs, 2 different bots in a video call talking to each other unmediated. Like they're actually, I think it's the text transcript that they're actually exchanging information through, but they're in a real video call. They're in a 2-party WebRTC system talking to each other. And the imagery is generated on the fly. So there's a bunch, as you all probably know, there's a bunch of diffusion image generation models that are getting better and better and faster and faster. And so those 2 images were generated on the fly from character descriptions. And there's more of that video where the images get weird because diffusion models are weird, and that's a whole nother fun thing. And speaking of weird, I think we've had some conversations in sidebars here about guardrails for LLMs and how they are. It's still not 100% clear how to deploy LLMs into many production use cases because of things like hallucinations and new classes of non-deterministic errors. When GPT-4 Vision was first released, we managed to catch this interaction. This was Christmas, obviously, last year, or obviously if you live in the US, because we were wearing our crazy Christmas sweaters in a test call.
Starting, wow, Mark, your holiday spirit is absolutely fantastic. The festive headband and that brilliantly detailed holiday sweater really make you the life of the party. You've set the bar high for holiday attire. Wonderfully done. Starting, wow, Chad, your festive Christmas sweater really brings a lot of holiday cheer to the party. Pair, Regis fingerprint. I got username, XML. Starting. Oh, well done, Nina. Not everyone can make the holidays look as light and merry as you do. I'd say your clever jumper pays fitting mo to both punts elderjations link hidden celebrator smime type jun instruments of txt del sim holidays from ante contemplates I've honor respect white 400 vendos on data change chronic markle style I mess him for their honor join JSON native election so you bind your render strategy URL and
So that's actually coming out of GPT-4, OpenAI standard HTTP endpoint. We gave it a prompt, we gave it a series of images, and that came out. So if you are building this stuff in production, you have to have evals, you have to have guardrails, and we're all still figuring out how to build that stuff. The architecture there was, again, just a WebRTC session, bunch of participants in the WebRTC session were grabbing frames from the video from each session and sending those frames to the LLM with a prompt. In that case, we were sort of prototyping like very simple Copilot stuff with vision, and the prompt was just sort of talk about what you see on camera in a friendly and complimentary way. And that capability is incredibly impressive. Like, we couldn't do this stuff 2 years ago with computers, but it's also not fully baked yet. So putting all that stuff together, all the things we've been trying to learn for ourselves and with customers, we now can build, I think, pretty good voice bots for specific use cases. Here's an example of a bot that replaces the filling out 4 forms every time you go to the doctor in the US. You fill out the same 3 to 5 forms with all the same information on them. It's probably specific to the US healthcare system, but they're probably analogs elsewhere in the world. And this is a bot that just calls you on the phone, or that you click on a link in an app, and it conversationally gathers all that information you would normally have to fill out the form for. And it puts a bunch of the pieces together that those sort of funnier demos helped us figure out.
Hello, chat. My name is Jessica, and I am with Tri-County Health Services. To ensure your privacy and to confirm your identity, could you please provide me with your birthday, including the year?
Yeah, it's January 1st.
I appreciate that, Chad. Can you also tell me
Oh,
the
sorry. Yeah, 1983.
Thank you for providing your birthday, Chad. Now, could you please list your current prescriptions, including the medication name and the dosage for each?
Yeah, I take lisinopril and also gabapentin.
Great. Could you please provide the
Oh,
dosage?
yeah. Sorry, 10 milligrams and 100 milligrams, respectively.
Thank
So the thing that we were really excited about when we first sort of got that level of functionality was working was it felt like a bunch of building blocks came together to create something genuinely useful and genuinely new. So you can script these conversations, but they are open-ended and conversational from the human perspective. There's interruption handling. It feels very natural. There's a bunch of information you're trying to gather that needs to go into an external system, and so you can trigger when you know you've gotten each of those pieces of information and actually make what the LLM world calls a tool call or a function call out to that external system. So if we take a step back, how do we help other people build these kinds of things? The conceptual model is really simple, right? It's like you've got a user on a device somewhere, they're talking to that device, and somewhere in the cloud there's a bunch of AI stuff running. And when developers come to us and they've just started down this road or they've built a prototype, it generally looks like this. These are the big moving parts. So you have to do transcription, you have to figure out when the user is done talking, then you prompt the LLM, then you take the output of the LLM and you send it to a voice model, you send that back to the user. Today you need to run all that stuff in the cloud because the models, the best models, all require more compute than the average user's device has. As Nikhil talked about earlier, that is going to change. There's going to be a lot of evolution of models and behaviors and where we run everything. But today, generally, you run all of this stuff in the little cloud bubble labeled AI, and you just move audio and video back and forth from the device to the cloud. That hides a lot of complexity, so there's a couple of threads here to pull on. Once you've gotten your prototype, which almost all developers who come to us to do this stuff, put another way, I've had like probably 100 conversations over the last few months with people who've built a prototype with this stuff and a WebSocket, and then they're starting to roll it out and they're encountering a ton of problems. And in this room, we all sort of know about those problems. It's things like echo cancellation, audio processing on the client side, firewall traversal, latency of the WebSocket stacking up unexpectedly when you start using this stuff with real world users, not just testing on your own network. Sort of the cloud starts to look like this. If we organize it a little more, it looks a lot more like something all of us are very familiar with in this room. But my experience over the last few months is that outside of this room, people don't have a mental model here of a media server that does a lot of work, plus a bunch of really nice components that run on clients that also do a bunch of work. So I do think we have an opportunity as a community to sort of teach people about WebRTC for these new use cases, because WebRTC is a really great fit for these real-time bots. You have a client running on the phone or the browser, and then you have an SFU somewhere in the cloud doing a bunch of heavy lifting, and then you have another client that looks like a headless WebRTC client that you can script somehow. But, of course, there's a whole new piece of this stuff that we're all just starting to figure out how to build. What actually runs in that headless context somewhere in the cloud? Like, what is the functionality? What are the right programmatic abstractions? Do we need toolkits? We came to believe that we do need new toolkits for the sort of headless AI stuff, the bots that are running in the cloud. So we built a few different versions of that toolkit internally at Daily, and then we open sourced it, the most recent best attempt on our end. And we really would love to have other people contribute to this. We'd like it to be truly flexible, composable, configurable, pluggable, and multi-platform. So the idea is, if you're building that AI thing that runs in the cloud, what are the hard problems that need to get solved, and how can we build little chunks of code that are super easy for developers who are new to this space to use in that context. There's things like audio and video transport, has to be very low latency, robust to network conditions, good fast transcription, sort of building these pipelines where you're moving data between these multiple AI models, the transcription model, the LLM, the speech-to-text model, the text-to-speech model. No, I always get that backwards at least twice, have to flip it, the speech-to-text model. Swapping out different models to do different kinds of testing, things like phrase endpointing, interruption handling, echo cancellation. What we were trying to do was build a framework that sort of gives you pieces for all of those that you can plug into pipelines. I really liked Plemislaav's talk. The pipelines are such great abstractions for media stuff. PipeCat looks a little bit like the pipeline slides he drew, but for this AI stuff. Since we're all programmers, just look at a little bit of code. This is all Python, and the reason it's all Python is because in the large language model and diffusion models world, everybody works in Python all the time. There is not anything else other than Python. So we built PipeCat in Python to play nicely with this new AI stuff. We do have a lot of people say, I don't want to use Python, I want to use JavaScript because I come from the web developer side of the world. That's totally fair and legitimate. I don't have a good answer to it. Maybe the answer is something like there are multiple languages that support all these abstractions, but we learn from each other about what the right abstractions are. In the non-real-time LLM world, we've seen a few examples of this, like LangChain and Llama Index. I think both now have both JavaScript and Python implementations where they're trying to kind of cover the same abstractions across two different programming languages. So maybe this stuff moves in that direction too. So cutting off the first 25 or 30 lines of a voice bot, which is all import statements, this is a complete voice bot of exactly the kind of you just saw in all the demo videos, and really the only piece of it that is kind of the moving parts, everything else is kind of configuration and setup, is a pipeline. So you have some kind of transport that's moving stuff around, and then you do some kind of aggregation after the transport so that you can feed the LLM data in the right format, and then you kind of pull sentences at a time out of the streaming response from the LLM, and then you feed to the voice model, the TTS system, and then you go send back to the transport to send over the network. And then at the very end, after the transport, because you want to handle interruptions and you want to maintain the state of the conversation mapped to what the user actually heard, you have one more aggregation of the sort of multi-turn context that the user and the bot are having when they talk to each other. So that's all of it. That's the kind of moving part. You can build a full voice bot with sort of just this much code. So what can you build? What have we seen people build with PipeCat? So conversational experiences of all kinds. I think we've probably had 20 or 30 young hackers in San Francisco build themselves a therapy bot, which is a really great use case actually, like a companion you can just talk to all the time. They talk to it when they're going for walks or runs or whatever, and we've actually learned a lot from a bunch of those kind of use cases, people sort of building something for themselves to talk to, which I didn't necessarily expect a year ago would be so kind of dynamic and interesting, but it really is. Speech-to-speech apps, we saw a video of that, so like language translators, other things that are kind of doing real-time audio manipulation. There are a couple of customers of ours that have like accent modulation models for things like call center use cases. So you have a call center somewhere in the world, and that call center can be localized on the fly wherever the person calls in from. Lots of voice-controlled agents are kind of a subject of experimentation. You saw some of that in the recent OpenAI announcements. They want to help you control your computer in various ways. The Apple AI announcements were a little bit similar, with Siri now being able to sort of dig into the whole app ecosystem and become the kind of glue layer that has never existed for apps, which is interesting. Voice-first user interfaces, can you control, for example, we have a bunch of customers in healthcare. It's been a long-running pain point for healthcare people that they have these complicated pieces of software that they now have to pay as much attention to as they pay attention to their patients when they're actually talking to patients. If you can make those interfaces actually voice-driven, it's potentially very transformative for that experience. And then the new stuff is real-time vision. So can you incorporate kind of real-time camera feeds, real-time imagery? This is what PipeCat supports today. This is sort of the list of features and kind of services that there are plugins written for. So my ask for everybody here is if you're interested in this stuff, kind of build plugins for all the stuff that you use and care about, submit PRs, including for transport. So today, obviously there's a daily transport, which we've spent a bunch of time trying to figure out how to make work well. Local pipes for people just doing kind of tinkering on a local machine, and WebSockets. WebSockets are totally fine for cloud-to-cloud use cases like kind of SIP interconnect-ish things. And almost every developer, like my experience is almost every developer who starts doing this stuff starts with WebSockets. So WebSockets are also like an on-ramp to doing this stuff, even if you're going to move to WebRTC. But we would love to have other WebRTC platforms be PipeCat transports. I think that's great for this whole ecosystem. So we will definitely support that from anybody who wants to do that. And if you want to be a PipeCat maintainer or you just want to hack on stuff, join the Discord, come hang out. It's actually really, really fun. I think that's it.